Today we undertake a hypothetical voyage to explore what we might see if we traveled close to the speed of light. Fasten your seatbelts, because as we approach the ultimate cosmic speed limit, things are about to get mind-bendingly strange. Imagine a spaceship with a revolutionary propulsion system capable of constantly accelerating us away from Earth. As we pick up speed, wouldn't the world just become a blurry mess? Interestingly, no. Here's why. Speed itself doesn't affect how we feel inside the ship. It's the acceleration, the push of the engines into our backs, that we'd actually notice. But as long as that push is smooth and gradual, it wouldn't be unbearable. However, there's a potential danger lurking in the vast emptiness of space. Tiny dust particles at these immense speeds could be like microscopic bullets, capable of inflicting catastrophic damage on our ship. To ensure a safe journey, we'll need a powerful force field that can deflect these miniature projectiles. As we begin our acceleration, the first optical effect we'd encounter is called Aberration of Light. Imagine yourself driving in a heavy downpour. The raindrops fall vertically, but from inside the moving car, they seem to hit the windshield at an angle. The faster you go, the more slanted. It's the same with light. As we zoom through space, the light from stars in front of us appears to come from a more forward direction. This makes the sky in that direction seem squished, like a giant cosmic accordion being compressed. Conversely, behind us, the sky stretches out and darkens, creating a vast, inky void. Another fascinating effect we'd witness is the Doppler shift. Remember how light has different colors depending on its wavelength? As we accelerate away from Earth, its light gets stretched towards the red end of the spectrum, making our home planet appear reddish. This phenomenon is akin to the sound of a siren changing pitch as an ambulance approaches and then recedes. In this case, the increasing distance between us and Earth causes the light waves to stretch, resulting in the red shift. Interestingly, this also implies that time on Earth seems to slow down for us compared to our reference point. Conversely, stars ahead of us would appear blue-shifted. Their light waves would be compressed, making them appear bluer, and their time would seem to speed up. It's like we're peeking into their futures, a consequence of our ever-increasing relative velocity. Now for the real mind-benders. According to Einstein's theory of special relativity, as we approach the speed of light, some very bizarre things happen. First, let's talk about time dilation. Imagine space-time as a giant four-dimensional fabric. Our spaceship and Earth are both moving along this fabric towards their futures, but the faster we go, the more our path deviates from Earth's. Time itself seems to slow down for us compared to those back on Earth. If we ever returned, we'd be younger than those who stayed behind. This isn't science fiction, it's a verifiable prediction of special relativity. Second, we have length contraction. As we hurtle closer to light speed, the universe in the direction of our travel would appear squished. This isn't just an illusion, the actual length of things contract. So, a distant star might seem much closer than it actually is. However, seeing this wouldn't be straightforward. Because light takes time to travel, the image we see of the contracted object is actually slightly outdated. This creates another cool effect called the Terrell-Penrose rotation, where objects appear slightly tilted. Imagine looking at a building from the side as you speed by on a train. The building appears to be leaning forward because you're perceiving its different sides at slightly different times. So can we keep accelerating and finally reach the speed of light? Here's the shocker. No matter how hard we try, we never will. As we approach light speed, it gets progressively harder to accelerate further. It's like the universe itself is pushing back, resisting our attempts to break the cosmic speed limit. Why? Because light is the ultimate speed limit. From our perspective inside the ship, light will always seem to be moving away from us at the same speed. It's a constant of the universe, an unwavering law of physics. Imagine this. As we approach light speed, our field of view shrinks dramatically. In front of us, a blindingly bright tunnel of light forms, while behind us, everything fades to complete darkness. All the optical effects we saw before become extreme. Light rays from in front seem to converge on a single point, like a cosmic spotlight illuminating our path. Those behind us, however, can never reach us, leaving us in an eternal cosmic twilight. From our perspective, the universe would be a thin sheet we could cross in a blink. Time would be distorted to an incredible degree. Minutes for us could translate to years for those back on Earth. We'd be travelers through time, hurtling towards a future that for them is still far off. It's important to remember that these are all consequences of special relativity, which applies only when an object is moving at constant velocity relative to another. In our hypothetical scenario, we're constantly accelerating. As we approach the speed of light, the theory's predictions become increasingly extreme, eventually reaching a point where they seem nonsensical. This is a clue that there's more to the story. Special relativity doesn't describe situations where gravity is involved. To truly understand what happens at near light speeds, we need to delve into the realm of general relativity, Einstein's theory of gravity. Since we can't outrun light with a conventional spaceship, what if we could bend space itself? That's the tantalizing idea behind the warp drive from science fiction. Imagine creating a bubble around our ship that warps space-time, allowing us to surf on a wave that travels faster than light. The ship itself wouldn't technically move, but the space around it would. This concept, while undeniably cool, is highly theoretical. Creating a warp drive would require manipulating negative energy, a form of matter that might not even exist in our universe. Even if we could overcome that hurdle, the amount of energy needed would be truly astronomical. But the beauty of science is that it allows us to dream big and explore the boundaries of what's possible. What happens beyond the speed of light? That's a question that even the most brilliant physicists can't definitively answer. Our current understanding of physics suggests that objects with mass can't reach or exceed the speed of light. However, there are theoretical concepts like wormholes and warp drives that could potentially allow for faster-than-light travel, but these remain firmly in the realm of science fiction, for now. Even though traveling at the speed of light might be a physical impossibility, the journey to explore it teaches us valuable lessons. It deepens our understanding of the universe and pushes the boundaries of human knowledge. It reminds us that the universe is a far stranger and more wondrous place than we can ever fully imagine. As we approach the end of our hypothetical voyage, let's take a moment to appreciate the incredible journey we've taken. We've witnessed the bizarre effects of special relativity, explored the concept of a warp drive, and pondered the mysteries of faster-than-light travel. Who knows, maybe one day, with enough ingenuity and perseverance, we'll be able to breach the cosmic speed limit and truly touch the stars. So, the next time you gaze up at the night sky, remember the wonders that lie hidden within it. The universe may have its speed limits, but our thirst for exploration knows no bounds. Thanks for joining us on this mind-bending journey, and don't forget to like and subscribe for more explorations into the extraordinary world of science. As always, Earthlings, stay curious and keep exploring.